So what's the optimal thing to do with S1? Somebody just said it. In fact, I wrote it down. Negative S0. So that means S1 of k is minus k for 1 and b and 0 elsewhere. Okay, let's assume the bits are equally probable. Let's do Z next. What's the optimal Z?
0.
Should be 0. Why?
Because it's in between, and since they're opposites.
That's right. So the expression for Z when 1 and 0 are equally probable is 1/2 S0 plus S1. But because S0 of k, negative S0 of k is equal to S1 of k, then negative S0 is equal to S1, so therefore S0 plus S1 is 0, so the optimal Z is 0. So those are the two easy parts. What's H? So I said H of k is equal to S0 at NB minus k. So let me redraw what S0 is. So what's NB again?
4.
NB is 4. So let's plot out H. Let's let k be less than 0. So if k is less than 0, then that's S0 of 4 minus some negative number. So that's S0 of like 5, 6, 7, 8. And what are all those values? Those are all 0. So over here, H of k is less than 0. Excuse me, H of k is equal to 0 for k less than 0. If k is 0, what is this? That's S0 of NB, which is S0 of 4, which is equal to what? 4. That's this coordinate. And k equals 1 is S0 of 3, which is 3. It's this guy. And similarly, what do I have here? 2 and 1. So that's H of k. So it's important to note that S0, it's support. I use the word support in the notes sometimes. What I mean by support is the area over which the function is defined. It sort of means the region in which it's expected not to be 0, although individual points here can be 0. But it's supported from 1 to 4, meaning everything outside of that range is guaranteed to be 0. Yes?
Does it really matter if H of k is shifted by any amount, as long as it's equal to something of Sk? Since you're convolving, it doesn't really matter.
Right. The only issue would be that you have to know when to take the output sample of your filter. So, for instance, if we did this, so here it's defined. Here the support is from 0 to 3. Here the support is from 1 to 4. And here what I'd have to do when I question mark.
With convolution, it just start from like 2, right?
That's right.
Yeah.
So if I convolve this guy and this guy, I get
before.
That one superimposed like so. That one is superimposed like so. And so on. So what I'm doing now is I'm reading off the coordinate at NB. If I do it this way, then this sample convolved of this function, now the convolution starts at 2 because this convolved with this, I basically take that and substitute it in starting at 0. So starting at 0 is here, and that's 0. So basically everything is shifted over by 1. So now I have this. And now I'm sampling an NB plus 1. So I strongly prefer that this is the way to do it.
So on paper, you get the same result because you're just summing.
That's
but
correct,
when you're
but
actually making it, matters.
as long as you are absolutely consistent about this shift. I prefer to say sample at multiples of NB, just because it's easier. But if you choose to do it this way, it's mathematically correct, but it's awkward when it comes to your. So I guess the question is, do you prefer the awkwardness in H, or do you prefer it in sampling? And I prefer it in H. Okay, so we have all of this. So here's my H. S1 is minus S0, H is that, Z is 0. So given all of that, you can go off and write some signal processing software that implements this system. So the final question is, what's the probability of error? In terms of RC and N0. Question?
So the HK that we chose here, that is the one we were just getting rid of the derivation of the previous classes. So basically, can we assume that the filter will be optimal this one or like in future questions? Do we have to show the derivation or just?
You can assume that it's up. Okay, probability of error in terms of RC and N0. What's the expression? I just wrote it down a second ago. So help me out here. How do I start?
Half RC.
Half RC.
Square root of dB over N0.
dB over N0. Okay, and I need this in terms of RC and N0, so what do I have to find? It's the only thing left. ED. I need the energy per bit. And that is equal to, how do I find that?
Square.
Let's start a little more fundamentally. What is, this is 1/2. Well, what it is probability 0, energy in 0, plus probability 1, energy in 1. And I already said those are equally probable. What else do we know about, or what else do you think is true about E0 and E1?